these are usually problems where you have to find a side length or something like that, find an angle, and there are basically the two formulas. It's the sine rule, sine A over A. So in other words, if I have a triangle ABC and I just name the opposite side lengths the lowercase letter, then the sine rule says that if I take the sine of this angle divided by its opposite side, it will be the same answer as the sine of any other angle divided by its opposite side. And the same would go for sine of C over C. Okay, what I want to show you is that we'll obviously only use two of them at a time. Okay, so I'm looking for an equation, I'm trying to find a side length. Now in this thing, just notice what you need. You need two angles and you need two opposite sides. If I had another side length but it wasn't opposite the other angle, then I won't be able to use it. So notice that there's 4 parameters in here. One of them I'm trying to find. Okay, so of the 4 parameters, let's say I'm looking for a side length. I have to have its opposite angle. Okay, so here's the condition. When will I use sine rule? Okay, I'll use sine rule if I have the opposite. If I have the opposite angle, or that's obviously I want the opposite angle if I'm looking for a side length, then I want its opposite angle, and or the other way around, or so either I must have the opposite angle or the opposite side, depending on what I want. And then what else do I need is I need another opposite pair. Okay, so there's 3 things I need: an opposite angle and then an opposite pair which consists of an angle and a side length. If I don't have those things, I can't use the sine rule. Okay, so sine rule, very simple in what I need. Now the cos rule. The cos rule says that if I take any side length, let's take side length A, the cos rule is associated with Pythagoras. So it would say a squared is equal to b squared plus c squared, but this would only be the case if it was a quadratic, right triangle. It's not a right triangle, so it gets this extra little expression at the back which takes the negative 2 bc cos, and now this angle that's in here is the angle that's opposite angle A, side length A, sorry. So in other words, if I want to use this one, notice again we've got 4 parameters. We've got 3 side lengths and an angle. So let's say I want to find, oh, you can't read that. Let's say I want to find an angle. If I want to find an angle, I must have the opposite side length. Doesn't matter which one of these 2 formulas I want to use, I must have the opposite side length. So what do I need if I want to find an angle? The opposite side, always. Now I see, once I have the opposite side length, the next question I'm going to ask is, what else do I have? If I have the opposite side, well, I must have the opposite side. Now the option is, I can either have one other side length and another angle, If I have a side length and another angle, then I should be able to get an opposite pair. So then I'll use sine rule. If I have all three sides, I'll use, so if I have three sides, I'll use the cosine rule. Let's do it like this, yeah. If I don't have three sides, but I have two sides, the opposite side and another side, two sides and an angle, then I will use the sine rule. Okay, that's if I want to find an angle. Let's say I want to find a side length. Okay, if I want to find a side length and I have its opposite angle, then I could still use this formula. You see, if I want to find A and I have the opposite angle, I could use cosine, but I can also use sine. It depends on what else I was given. So if I have its opposite side, I can use either one of the two. If I have two more sides, so I want to find a side length. If I have two sides, I will use cosine. If I have an angle plus a side, I will use sine. Okay, you don't have to go and study when will you use what. You can just look at the formula and see what do you have, and in the two formulas you'll tick what do I have, and then you'll see which one can I tick first. I need three things. Which one can I tick first? Okay, but if I don't have an opposite side, then I can't use the sine rule. If I want to...
Sorry, sir. Did sometimes specify?
What?
Like using cosine.
I haven't seen a question like that, no. But sometimes it can only be one, most of the times. If I want to find a side length and I don't have an opposite side, the opposite angle I mean, then I'll have to use cosine. And which means I'm trying to find a side length. I can't use cosine. I'll have to have its opposite. No, I can find one of these. I don't have its opposite side, but I will need at least...
If you don't have B and C's opposite.
See, so for example, if I want to find B's answer, I don't need B's opposite angle, you see, but I need at least one opposite pair. So you can see one of the most important things to do is find opposite pairs, because and so look at this question, for example. In which triangle can you see at least one opposite pair? In other words, you know the side length and you know the angle.
Angle ABC. No. Angle DAB.
What?
Angle D. I mean triangle, sorry.
Yeah.
DAB.
DAB. You see in this triangle I have an opposite pair. I know that's a 90 degree and I know that is 2. Now the moment you have an opposite pair, all you need is one more piece of information about that triangle and you should be able to get everything in that triangle. Okay. let me show you. We can get everything in this triangle. If that is x, this is 90, then this must be 90 degrees minus x. Okay? Since it is a 90-degree triangle, I've got all the opposite pairs. I can use my sine rule. But since it's a 90-degree triangle, it is, I don't even need to use sine or cosine rule. I can just use my normal ratios. So for example, if I wanted to know how long AD is, I see, well, I want AD. I have AB. So I'll use opposite. So this will be my angle. I want opposite over hypotenuse. That is sine. So sine of 90 degrees minus x is equal to AD over 2. So now I just solve AD and I simplify. 90 degree minus is cos. So AD would be, I multiply both sides with a 2. So it will be 2 cos x. So AD's length is 2 cos x. Let's look at BD. What is BD's length? BD is, I could just use this one. The x, it's simpler, and I could say that this is its opposite side length, and that's still the hypotenuse. The hypotenuse stays the same. So I can also use sine. I can say sine of x is equal to opposite, which is BD, over 2. So BD is equal to 2 sine x. So now I have an answer for BD, 2 sine x. Now the moment I've done this, can you find now a new triangle with an opposite pair? I filled in more values, so can you find another triangle that has an opposite pair? BDC. I've got 2 sine x here, and there's its opposite angle. Okay? What do you guys want to calculate? BC or DC? Well, let's look at the question. They ask us for BC. So let's go calculate BC. So in this case, I don't have a 90-degree triangle. Guys, even though this might look somehow like a 90-degree triangle, you cannot assume it unless they say it. Okay? So if I have an opposite pair, and I want to calculate BC, what other information do I have? Angle, and I'm trying to find that angle's opposite side. So I have already an opposite pair, and I want to use another opposite pair. So which formula am I going to use? Sine. Sine. Does it make sense that sine is really the opposite pair's formula? So I will have that sine of angle D divided by BC is equal to sine of angle, now the angle that I have, C, divided by BD. And now now I substitute what I have. I have that sine angle D is 90 degrees minus x. BC is what I'm trying to calculate, so I'll keep them like that. C is 2x, so sine of 2x. And BD, we've calculated it already. We said that's 2 sine x. And all we do now is we solve this equation. Before we go into solving this equation, let's just make it simpler first. We apply our reduction formula, co-ratios, Pascas and das. Positive, acute, and simple. So here we can see sine of 90 degrees minus theta changes to, so cos of x. BC, we'll just keep it like this for now. What would we do with sine 2x?
We expand it.
Of course. But sir.
So much work. Aren't we complicating the situation?
Look how simple it is. What do you mean complicating it? Look.
Looks better.
No, it doesn't. Because look here. Sine 2x cos 2x. If you knew that sine 2x is 2 sine x cos x, you will see that these two can now cancel.
5 minutes gone just for explaining this.
Oh, I can't believe you just said that. That's like blasphemy to me.
So without explaining, you can't, there's no other way.
No. It's not a, you see, Pandila, it is, if you recognize that sine of 2x is 2 sine x cos x, you will immediately see that sine x that it's expanding is going to cancel with that one. So in your mind's eye, you will see it actually simplifies the thing. It doesn't complicate it. But other than that, you can probably get BC on its own first, but you won't be able to simplify after that. Because the thing is, the whole aim is to get rid of this sine x somehow. And the only way it's going to get rid is if this one expands to release his sine x. Okay. Now, look at this. They asked us to show that BC is equal to 1. What do I have to divide cos x with so that my answer is cos x? No, cos x divided by cos x is 1. What must I divide cos x with so that my answer is cos x? Huh? What must I divide 2 with so that my answer is 2?
With 1.
Nice. So BC must be 1. What must I divide cos with so that it stays cos?
Oh my goodness.
1. No, you can't say it like that. You make me sound like I'm the silly one.
You should put these hints in the example.
It's not. No, I tell you what you guys should do is think. That's really all. I promise you. All you have to do is think. You guys want to use magic formulas in every step. You want to know what to do in every step instead of thinking what you should do. So there was different ways. Obviously, you can now just multiply both sides with a BC. Multiply with a BC. And so it cancels this side. But now you want to get BC on its own. So you have to divide with cos x on both sides. Cos x. So it cancels this side. Cancels that side. Leaves me 1. But doing that and just recognizing, but what must I divide cos x with to get cos x? And in any way, they gave you the answer. They told you what you should prove. They told you BC is 1. So at any point where you can actually see, in this case, BC has to be 1. Therefore, BC is 1. Okay. Let's look at the next one. Then they say, if AC is the square root of 3, calculate the size of ABC. So AC, they now give us the information there, that's square root of 3. Now they ask us to calculate the size of ABC. So this ABC, this angle here. Can you see in which triangle we're working with? In that triangle, what information do we have? First of all, do we have an opposite pair? If we don't, we're screwed. Yes, we do. We don't. It's not that we have it, but we want to use it. We have that one, and we want this one. Okay, so either sine rule or cos rule, both of them can use that opposite pair. Okay, then now it just depends what else do I have. Remember, I've just shown that BC is 1. So what else do we have?
We have 3 sides.
We have 3 sides. The moment you have 3 sides, you actually know which formula you're using, because the sine rule doesn't have 3 sides in it. So we know we're going to use 3 sides. We're going to use the cos rule. So, and the pair that we have, that's the one that should come on the left hand side. So we will have b squared is equal to a squared plus c squared minus 2ac cos of b. And b is what we're trying to solve, so we should have all of the other angles. This one they told us is square root of 3. A we know is 2. No, a is 1. A is that one. So that's 1. C is the one that's opposite C. It's 2. Minus 2 times 1 times 2 times cos of angle B. Now this is a equation. Okay, quadratic equation. What's the aim of a quadratic equation?
What's the what?
Aim of a quadratic equation. The main aim, I said there's 3 things, but the main idea
is to get
single trig ratio, which in this case is going to be my cos beta equal to a constant. So that's what I'm going to do. I'm going to have 2 times 2 is 4 cos beta is equal to 1 squared plus 2 squared, that's 5 squared. And this side is going to be a 3. When the 3 goes to the other side, it's negative 3, so it's 5 minus 3 is 2. So cos of beta, if I divide the 4 on both sides, I will get cos of beta is equal to a half. Now one thing you can be fairly confident about is that when we do, when we're working with 2D and 3D problems, we're working in reality, there's no negative angles. Does that make sense? So I don't, if I get the reference angle, my reference angle is my answer. Okay, I don't have to add 360 because what does a 720 angle in reality look like? Do you understand? We can't have an angle in reality that's more than 180 degrees. The moment it's more than 180 degrees, the triangle is on the other side. You see, so an angle will always be less than 180 degrees, which means, and your reference angle always is less than 180 degrees. So cos of B, this is 6. No, it's not.
It's not.
It is, you're right, sorry.
Yes, it.
No, it is. Sorry, I'm confused. Okay. Great. So, guys, I'm sorry. This is the first time I actually noticed how to do some of these things. I'll just have a systematic approach to it, and that is to find the triangle with the pair, the opposite pair, and use whatever other information you have it to fill out all of the information that you can using your sine and cos rule, and then start looking at the questions that they have, or you can start filling out more information by finding new pairs, opposite pairs. That seems to be a good approach to these questions.